So, good morning everyone. So, today we will study transient analysis of synchronous machine using DQ0 variables. Okay. So, the transient behavior of synchronous generation is quite important because this analysis helps in determining the shaft stresses, winding and bus bar stresses, protective relays setting, and circuit breaker duties and their ratings. Okay. So here we will find the nature of the current resulting from the sudden three-phase short circuit at the synchronous generator terminal. Okay. So here we will not consider the damper windings. Okay. And some assumptions were made during this analysis. So machine is running initially at no load and under steady state condition, and speed before and after short circuit remains unchanged from its synchronous speed omega. Okay. So here we will discuss the nature of the current from a sudden three-phase short circuit at the terminal synchronous generator terminals. Okay. So, in the last class, we have derived the stator voltage equations with help of path transformation. Okay, in terms of dq variables. Okay, so we will first write down this voltage equation, and we will derive the equation of current id and iq, d axis and q axis current. Okay, so around the axis and q axis. So and then we will convert this ID and IQ into the respective three-phase current. So this two-phase current ID and IQ will be converted to three-phase current IA, IB, and IC. So we can analyze the effect of the short circuit at the terminal. Okay. So first we will write the voltage equation of the synchronous generator, and then we will derive the ID and IQ, the axis current and Q axis. Okay. So first, voltage equation for synchronous generator. Okay. So first we will write the voltage equation for synchronous generator. So the equations are Vf is equal to Rf plus Lf into P into If minus Md P, and Vd is equal to Md P If minus Ra plus Ld plus Lq omega R. Q axis voltage is Md omega R If minus Ld omega r into ID minus RA plus LQ into P. Okay, so these are three equations. So using our equation for obtaining the solution of the transient problem. Okay. So first, we assume that all the resistors are neglected. Okay. All the resistors are neglected. So we are neglecting this field resistance and armature resistance. Okay, so we are neglecting this resistance and let the alternator speed omega r is equal to omega. Okay, so it is running at synchronous speed. So we are neglecting this field resistance and armature resistance. Okay, so the equation will become, so this will be here is equal to RF is neglected LF into P into IA, where P is equal to d by dt. Okay. This is field current minus MD PID. This will be VD is equal to MD PIF. RF is neglected. I. This will be LD PID plus LQ omega R and DQ is equal to MD omega R IF minus LD omega R ID minus LQE. Okay, so this is the voltage equations of the stator of the alternator in DQ variables. Okay, where all the resistance are neglected. Okay, so from here, so this is like this is equation number 1. Now, so before the short circuit, that is at t is equal to 0 minus, the armature current IA and IB and IC are 0. So IA is equal to IB is equal to 0. Okay, so this is before the short circuit, and therefore both ID naught and IQ naught. So ID naught and IQ naught is equal to 0. So this depends on this. So in last class we have seen that ID and IQ depends on IA, IB and IC. Okay. So this subscript naught is added to indicate the values before the short circuit. Okay. So where we write this naught, so this indicates the value before the short circuit. Okay. So since ID is equal to 0 and IQ is equal to 0, so the equation, this equation reveals that so if ID and IQ are is equal to 0, that means VD naught. So this all is 0. So VD naught will be equal to 0 and VPQ naught will be equal to MD. This MD omega r IF naught. Okay, so when we substitute these values in this equation 1, we get Vd naught is equal to 0 and IQ naught is equal to Md omega F naught. The effect of short circuit is to reduce the generator terminal voltage to 0. Hence, Vd naught will be equal to 0 both before and after the short circuit. Therefore, short circuit current has no effect on Vd. Okay, so this has no effect on the Vd. And voltage Vq naught will be equal to 0 after the short circuit. But before the short circuit, it will be equal to Md omega r into If naught. Okay. So thus the effect of short circuit is to reduce Vq naught to suddenly 0, and it can be taken as a small step voltage. Okay. So this can be written as Vq naught into 1. Okay. So the VQ naught is reduced by application of a step voltage to the Q axis terminal. So both and after short circuit, the voltage applied to the field winding VF, therefore superimposed voltage VFT. So this is VFT, and for the field windings it is 0, is equal to 0. Okay, so for short circuit. So what we do, we generally if we finding the values of the current and voltage when sudden short circuit is happen. So first we write the values before the short circuit, and then write the values after the short circuit, and then we add them. We superimpose them. Okay. So this is step function voltage. What we do, voltage and current after short circuit is equal to their original values before short circuit, their original value before short circuit plus their superimposed values resulting from short circuit, where superimposed values resulting from short circuit. Okay, so we generally superimpose this. So voltage and current after the short circuit. So before the original value before the short circuit, and then we add their superimposed value resulting from the short circuit. Okay. So in this way we can find the values of voltage and current after short circuit. Okay. So Vf is 0 and Vd is equal to 0. Okay, so Vd will be equal to 0 and Vf is also equal to 0. Okay, and Vq is replaced by a step function voltage. So this is Vq not 1. Okay, so this means this is a step voltage. Okay. So from this equation, we can find the value of IF. Okay. So from this equation, so LF into P will get cancelled out. Okay. LF IF is equal to MDID. Okay. So IF will be equal to MDID upon L. Okay. So this will be, the value of IF. Okay. So we will substitute this value of IF in remaining two equation, and we will find the value of ID and IF. Okay. So now substituting the value of IF here in this equation here, so this will be equal to, so this equation will become 0 is equal to MD into P, and it is IF, so MDID upon LF minus LD P into ID plus LQ omega into. Okay, so we have substituted the value of IF here. Okay, so here it is ID, so we can take out. So this will be MD square. Okay, and it is E upon LF minus LD into P into ID plus LQ omega. Okay, so you can take P also outside, so this will be MD square minus LD upon LF PID plus LQ omega IQ. Okay, so let this be equal to, you can write it as minus LD dash P into ID plus LQ omega into I. Okay, so where, so this is very lengthy derivation. Okay, so this is equal to 0. So where LD dash is equal to LD minus MD square upon L. So LD dash is equal to LD minus MD square upon LF, and it is known as dx is transient inductance. So this is dx is transient inductance. Okay, so this is dx is transient inductance. Okay, so now we will find substitute IFT in the third equation. Okay. So now substituting the value of IQ in this equation. The equation is EQ naught 1 is equal to MD omega IFT minus LD omega ID minus LQ P. Okay. So here we will substitute the value of IF. So this will become MD into omega. This is IF. So MD ID upon LF minus LD omega ID minus LQP. So this is MD square omega ID upon LF minus LD omega ID minus LQP. Okay. So again take omega ID constant. So this will be MD square upon LF minus LD into omega ID minus LQP. Okay. Pushatan. Pushatan. Hey, Pushatan. Pushatan. Hey, Pushatan. So this is equal to minus LD. Okay. This can be written as minus LD dash omega ID minus LQ P into IQ. Okay. So this is equal to EQ naught a step function. Okay. So we have got two equations. So let us this equation number 3 and this is equation number 2. Okay. So we have got these two simultaneous equation in ID and IQ. So from here you can find the value of IQ from this equation. Okay. So from this equation IQ is equal to LD dash PID divided by LQ into omega. Okay, so this will be the value of IQ by using equation 2, and we will substitute the value of IQ in equation number 3. Okay. So EQ naught 1 is equal to minus LD dash omega ID minus this term in terms of in place of IQ this will be equal to LD dash PID into LQ is LQP, it is LDPID divided by LQ into omega. Okay. So this will be equal to, you can take ID common. Okay. So LD dash and ID taken out. So this will be omega minus, this will be T square plus omega. Okay, like this. Or it can be written as minus LD dash ID upon omega, omega square T square divided by this. Okay, so this is the value of VQ naught. So this can be written as minus LD multiplying omega in numerator and denominator. So this will be into omega, omega square T square divided by omega square. Okay. So from here ID will be equal to, so this is equal to minus Q naught 1 divided by LD dash into omega. This will become omega square upon omega square plus T square. Okay, like this. So this above equation is in complex domain, and we can convert it into this in Laplace domain. So converting this into Laplace domain, so this will be equal to VQ naught 1 ID omega. So this is a step function. Okay, so you can write here. And Laplace of 1 is 1 upon s. Okay, so this will be, and LD and x cube is can written as omega into inductance is equal to xd dash. It is dx is transient reactance. Okay, so this is xd dash. Okay, and this will be 1 upon s, and this is omega square s square plus omega square. Okay. Now, by using partial fraction, you can find the value of 1 upon s omega square s square plus 1. So 1 upon s omega square s plus omega square will be equal to a upon s plus b upon s plus j omega plus c upon s minus j omega. Okay. So on solving this, a is equal to 1 and b is equal to c is equal to minus half. Okay. So IDS will be equal to, so this there will be no, this will be VQ naught divided by ND. Okay. So this is 1 upon s minus half 1 upon s plus j omega plus 1 upon s minus j. Okay. This can be written as VQ upon XD dash. So this 1 upon S minus this will be 1 upon 2s divided by x square plus omega square. So this is equal to VQ naught XD dash. So 2 cancel out. So we get 1 upon S upon S square plus omega square. Okay, now we will take inverse of this equation, Laplace inverse of this equation. So ID of T will be equal to VQ naught upon XD dash. 1 upon S, inverse upon 1 upon S is 1. And Laplace inverse of x upon x square plus omega square is cos omega t. So this will be minus cos omega t. Okay, so this is the value of transient d-axis current. Okay, so this is transient d-axis current. Okay, and it consists of, so we can write it as ID VD naught upon XD dash minus VQ naught upon T dash into cos omega. Okay, so it has got two components. So one is, this is DC component. Okay, and the another one is fundamental frequency component. This is fundamental frequency. Okay. So this is the value of d-axis current, transient d-axis current when sudden three-phase short circuit occurs. Okay. So we can find the value of IQ naught also. Okay. So the relationship between ID and IQ is, so IQ is equal to LD dash P omega LQ. Substitute the value of ID, so this will be IDT as a function of time. So this is LD dash P upon omega LQ, and this is what ID. This is ID is equal to this VQ naught divided by XD dash minus VQ naught divided by XD dash cos omega. Okay, so this is Q axis transient current. Okay, and again it has got two components, one DC component and okay. But here it is P, that P is del D by dt. Okay, so IQ P, if we take on this ILD dash by omega LQ, V naught is taken out, DQ naught and XD dash. So we left with 1 minus cos omega. And this is P. Okay. What is P? P is, so this will be equal to LD dash VDQ naught divided by omega LQ XD dash d by dt 1 minus cos omega t. Okay, differentiation of 1 is 0, differentiation of cos omega t is omega sin omega t. So this will be equal to LD dash VQ naught into omega sin omega t divided by omega LQ XT dash. Okay, and we know that this XD is equal to LD into omega. So this can be done as XD dash VQ naught sin omega t divided by omega LQ into XD dash. So this will be cancelled out. So VQ naught sin omega t divided by omega LQ. Okay, and we can write omega LQ as omega LQ is equal to x cube. So this can be written as VQ naught sin omega t divided by x. This is the value of transient QXs. So it consists of only fundamental frequency component. Okay, so this gives the variation. So we can find the values of IB, IC and IA using this IQ and IA. Okay. So let's draw the variation of IQ and IB. So this is IB T with respect to time. Okay, so this will vary like this. Okay, so with omega t. So this is ID of t and this is DC current. Okay, so IQ is this much and ID is equal to VQ on XD dash 1 minus cos omega. Okay, so this is VQ upon XT. VQ naught, this value is VQ naught upon XD. Now, IQT as a function of time. So IQT is sinusoidal wave. So I naught is equal to E naught upon sin omega t into XQ naught. Okay, so this is sinusoidal. So this will be a sinusoidal waveform. Okay, so this is 2 pi. This will be fine. This is 4 pi. So this is IQ t. Okay, and the maximum value is also same VQ naught divided by x. Okay, so this is the variation of the d axis current and transient d axis and q axis current. Okay, and we also draw the field current, transient field current I of t. So this is equal to, so this will start from here. Okay. This is okay, and this value is, so we will derive the values of IF later. Okay. So then we will see this is I naught XD upon XD dash. Okay, and this value of is IF naught XD minus, this is IF naught is xd by xd dash minus. Okay. So this is the variation of IA, IP, ID and IQ, and with respect to time for a sudden three-phase short circuit. So this is variation of ID T, IQ T, and IA T for sudden three-phase short circuit. Okay, so when a sudden three-phase short circuit occurs, this will be the variation of the ID and IQ. Okay, and this will be the IA. So we will derive this later in this lecture. So this is IA. This value is IA. Okay. So now we will convert this ID and IQ into three-phase current using Park's transformation. So the relationship between IA, IB, and IC with ID and IQ is given by Park's transformation. So IA, IB, and IC is equal to 2 by 3 root 3 cos theta minus 120 degree cos theta plus 120 degree minus sin theta minus sin theta minus 120 degree plus 120 degree 1 upon root 2 1 upon root 2 1 upon root 2 ID IQ and I. Okay, so this is the relationship between three-phase current and two-phase current ID and IQ. Okay, so from this matrix it is clear the value of IEA is equal to root 2 by 3 cos theta into ID. So ID cos theta minus sin theta into IQ sin theta. So in this way, we can find the value of IA, IB, and IC. Okay. So this two-phase current, D-axis current and Q-axis current, is converted back to three-phase current. Okay, by using this transformation. Okay. So now we can easily find the value of IA, IB, and IC. Okay. So in this equation, we will substitute the value of IQ and ID. Okay. So before that, this is phase A, and it is making an angle with d axis is theta naught. This is d axis, and this is y axis. Okay. So at the instant of short circuit, the axis of phase A is assumed to make an angle of theta naught with the d axis. Okay. So at the instant of the short circuit, since the rotor is running at the synchronous speed of omega, the angle theta between d axis and phase A at time t seconds is given by, so it will increase by theta is equal to omega naught by theta naught. So this will be increased by omega t. So now the angle, so this is phase A. So this will become theta is equal to omega t plus theta naught. Okay. So theta is increased by omega t. So phase axis A is displaced by omega t plus theta naught at any time t. Okay. So it is at any time. Okay. So now we will substitute the value of ID and IQ in this equation, and we will get IA. Okay. So IA is equal to under root 2 by 3. Okay. And VD is, sorry, ID is VQ naught upon XD dash 1 minus cos omega t plus theta naught. Okay. So this will become omega t plus theta naught, okay, into 1 plus cos theta. Sorry, 1 minus omega. One minus cos. And so this become so theta is increased by omega t plus theta naught. Okay. So then we will substitute the value of IQ. It is VQ naught upon X naught. Okay. And again this will be increased by, so this is cos. This is sin omega t plus theta naught into cos omega t. Okay, so there is, so sin as ID is equal to VQ naught upon XD 1 minus cos omega t, and IQ is equal to VQ naught upon X cube sin omega t. Okay, so this is the value of ID and this is the value of IQ, and here theta is increased. Theta is equal to omega t plus omega naught, and sin is omega t plus theta naught. Okay, so IA will become after further simplification. So this will become Vt naught upon Xd dash. Okay. So this will be cos omega t plus theta naught minus Vq naught Xd dash cos omega t plus theta naught into cos omega t. Okay. And this will be minus q naught upon x cube sin omega t plus theta naught and into sin omega t. So we have to apply the formula, cumulative formula, sin A, sin B, and cos A, cos B. So cos A, cos B is equal to half cos A plus B plus cos A minus B, and sin A sin B is equal to half cos A minus B minus cos A plus. This is the value of sin A sin B. Okay. So this will become Ia is equal to under root 2 by 3. So this is equal to, so this will be same Vq naught upon Xd dash cos omega t plus theta naught. So this is cos A, cos B. So minus Vq naught divided by Xd dash. So first cos A plus, so A plus B, so divide by 2. Okay. So cos A plus B, so this will become cos 2 omega t plus theta, and then A minus B, omega t will cancel out, so plus cos theta. Then what is Vq naught upon x cube, so this will be sin A minus B, so omega t will cancel out, so sin theta. So cos theta, it is sin theta naught minus sin A plus B, so this will be 2 omega t plus theta. Okay. This will be equal to root 2 by 3 Vq naught upon Xd dash cos omega t plus theta naught. So so this term, so this will be cos. Okay. So taking this cos out, okay. So taking negative here, so Vq naught divided by 2. Okay. This is 1 upon Xd. Right? Here it is 1 upon x cube, 1 upon x cube into cos 2 omega t and minus Vq naught upon 2, so this will be 2 cos theta and cos theta. So this will be 1 upon x d dash plus 1 upon x cube into cos theta. So this is the value of I A of, so this is I A of. Okay. Now before the short circuit, that is at t minus 0. So before the short circuit at t minus 0, t is equal to 0 minus the value of VQ is equal to, sorry, VQ naught is equal to MV omega IF naught is equal to root 3 E. Okay, EF naught. Now substituting these values, VQ naught here. So taking VQ naught outside. Okay. So this will be equal to root 2 times IAT. So this there is root 3. So this will be get cancelled out. So this will be root T root 2 EF naught. Okay, divided by XD dash cos omega t plus theta naught, then minus root 2 EF naught divided by 2, 1 minus XD dash minus 1 upon x cube cos 2 omega t minus root 2 EF naught divided by 2, 1 upon x cube, 1 upon xd dash plus 1 upon x cube cos theta is equal to cos theta. Okay, so this is the value of the current IB and IC can be obtained by replacing theta. So theta minus theta naught. So if you replace theta naught by minus theta naught, so you will get IB, and if you replace theta minus 240 plus 120, give you IC. Okay, so theta minus 120 degrees and theta minus 120 degrees gives you IB, and theta minus 240, theta naught minus 240 gives you IC current. Okay, so this is the equation of the phase current IA. Okay, the first term in this term, so first term is termed as fundamental frequency component. Okay. So this term. Okay. So this term is fundamental frequency component. Okay, and second term is second harmonic component. Okay, so this is 2 omega t. So this component is second harmonic component. And this third component is the DC component. Okay, this is sorry, forget this not. And this is DC component. Okay, so this phase current IA is consists of fundamental frequency component, a DC component, and a second harmonic component. Okay, so this reveals that magnitude of the fundamental DC and second harmonic depends on the pre-fault excitation F naught. Okay, so it depends on free excitation. This CF naught is depends on this pre-fault excitation, that is IF naught. Okay. So as this is independent of omega t, so this is a DC component. Okay. So we have got these three components: fundamental frequency component, second harmonic component, and DC component. Okay, so due to this sudden three-phase short circuit, IEA consists of these three components. Okay. And here 1 upon xd minus 1 upon q is also known as transient saliency. So second harmonic component, that is xd dash minus 1 upon xq, is the magnitude of the second harmonic component depends on this term, which is called as transient saliency. Transient saliency. Okay. So if you write I B of P, so this will be equal to root 2 F naught by XD cos omega t minus plus theta naught minus 120 degree. It is replaced by 120 degree minus root 2 EF naught by 2 1 upon XD dash 1 upon x2 is cos 2 omega t plus theta naught minus 120 degree and minus root 2 EF naught by 2 1 plus xd is 1 upon x2 into cos theta minus. So this will be the value of phase current IB. Similarly, you can write the value of ICT. So this will be theta naught minus 240, theta minus 240, and theta naught minus 240. So this is the value of the phase current under the sudden short circuit. I have considered the terminals of the synchronous generator. Okay. So the DC component ID becomes fundamental frequency component of the phase current ID, and fundamental frequency components of ID and IQT gets transformed to DC and second harmonic component of IAT. Okay, so we can draw the variation of IA, IB, and IC after application of sudden three-phase short circuit. Okay. Okay. So this is IA T. This is omega T. This is with respect to T. Okay. So the current will start, and the with the envelope of the short circuit. With the envelope of the short circuit. Okay, so current this is in the, and then after science. And this is the DC. So this will be the variation of the phase current IT when a synchronous generator is on the application of short circuit condition. Okay. So this is envelope of short circuit current. Okay. So this is a transient condition. Okay. And after some times it settled down to the steady state condition. Okay. Similarly, we can talk about I P of T. This will be the envelope of the short circuit current. And this is the DC component. And IC T. So envelope is this will be DC. This should be plus negative. So the armature current of the synchronous generator after application of sudden three-phase short circuit. This is the equation. Okay. So similarly, we can find the value of field current. Okay. So transient field current can be obtained by substituting the value of ID. Okay. So IFT of P is equal to MB by so we know that IFT is equal to LF upon IDT. Okay. And IDT is equal to VQ naught upon XD 1 minus cos omega t. Okay. And VQ naught is MD omega naught into IF naught. Omega into IF naught. So this will become IFT of T will be equal to MD by LF into MD omega IF naught 1 minus cos omega. Okay, so this will be equal to MD square omega IF naught by LF minus MD square omega IF naught divided by LF cos omega. So the total field current, so total field current, so IF will be equal to IF naught initial free fall and then superimpose value of IFT during fall. Okay. So this will become I. So substituting the value of IF naught here. Okay. So this will be smaller. So IF naught plus MD square omega IF naught divided by LF minus md square omega I at naught divided by LF cos omega. So taking I at naught common, so this will be equal to I at naught 1 plus mv square omega by LF 1 minus cos omega. Okay, and we know that LD dash dx is transient difference is equal to LD minus md square by LF. Okay, so md square upon LF can be written as LD minus LD dash. Okay, so substituting here, so this will be equal to I at naught 1 plus LD minus LD dash omega upon LF 1 minus cos omega t. Okay, and what is this L into omega into L? It is inductance, reactance. This will be 1 plus XD minus XD dash upon LF 1 minus cos omega t. So here will be 1 upon XD dash. XD dash. So this will become XD dash. I will be equal to I at naught 1 plus, this will become xd upon xd dash, xd upon xd dash minus 1 minus cos omega t. Okay. Multiplying this, so this will be I at naught 1 plus xd by xd minus 1 minus xd by xd dash cos omega t plus cos omega t. Okay. So then we will get cancelled out. So this will be I at naught 1 plus xd by xd dash 1 minus cos omega t plus omega t. Okay. So we can write it as IFO is equal to ISD minus dash SD minus 1 into cos omega. Okay, so this is the field current consists of fundamental component and a DC component. Okay, so this will be the DC component and this will be the fundamental frequency component. And if we draw the variation of the field current, so this will be the envelope like this. And this value is I, field fault with respect to time. Okay, so this is all about transient analysis of synchronous generator. Okay, thank you class.